Hello, this is a talk on Arabic language computing applied to the Quran, a PhD research project by Kais Dukes in the Institute for AI and Biological Systems at School of Computing at University of Leeds. If you Google Kais Dukes, you'll discover his website, which shows he's a financial software engineer in the financial industry at City of London. He's also doing a part-time PhD. Unfortunately, he's very busy at the moment and unable to present in person, so his supervisor Eric Atwell, is presenting this for him. The challenge is to try and find an interdisciplinary approach to understanding the Quran, using ideas from Quranic studies, traditional Arabic linguistics and computational linguistics, and hopefully feeding back to all three areas. Now, the Quran is the last in a series of 5 major religious texts. The idea believed by believers is that God gave the message to the angel Gabriel, who passed it on to Muhammad to learn by heart and pass on to all believers. It's written in the language of 1300 years ago. All believers are supposed to try and understand the original, in fact, the original text, rather than translations or interpretations. It has guided philosophy, science, and other aspects of knowledge, particularly Arabic linguistics, which was developed to try and help understand the Quran. And it's been the guiding light in theories of syntax, semantics, and discourse analysis, used today on modern English too. As far as computers are concerned, there are many websites where you can access the Quran, but you can only search for verse by verse. You can search for individual verses which contain words, so it's basically Google-style searching. It would be nice in theory to be able to ask questions in plain English like, how long should I breastfeed my child for? And have an AI system which finds the English to find. Machine learning works by taking data, adding additional information to the data, and then learning from this data new patterns to find answers. The Quran, because the text is written in a non-standard script like modern standard Arabic, has complex morphology, very difficult grammar and semantics. But there are possible solutions. If we look at modern AI, we can get hold of the original text, extract the meanings of the grammatical descriptions, use his training machine learning, and then put it online for volunteers to correct. The first task is to get hold of an authentic version of the text, because if you just use modern Windows, Unicode, or other modern sources, modern standard Arabic, it doesn't display it correctly. Luckily, there was a project, the Tanzil project, which started around the time that Kai started out this research effort, which came up with a Unicode XML encoding which allows the text to be displayed authentically in its original form. So Kai's had to start by developing a Java API, or a large set of code, which allows you to read this XML and display the original text authentically on a web page. This then allows us to do morphological analysis as the next stage, and there are tools for morphological analysis for modern standard Arabic, and there has been some progress on analysing the Quran at University of Haifa. There's also lexical semantic representations developed at Columbia University. The trouble with the Haifa corpus is that it didn't really complete it, so each word has got many possible analyses, and they were not verified by experts or who knew what was correct, and it's an non-standard annotation scheme. So Kai's answer was to develop the Quranic Arabic corpus website, do a lot of analysis, and put it all online for people to see and use and to correct if necessary, including word structure, word translations, grammatical and semantic representations. So here we have the base is the verified Uthmani script for a word. You have to read the Arabic from right to left. Of course, if you don't speak Arabic, this doesn't mean much to you, but if you do speak Arabic, you can see it is the correct original format. For non-Arabic speakers, there's also a phonetic transcription, not using true international phonetic alphabet, but something like the standard Roman alphabet, so that English speakers, if you learn English as a second language, you can probably work this out. Also, the assumption that most learners of an awful lot of learners of the Quran do speak English, so we've added an interlinear, word by word, exact translation of what the Arabic morphemes mean. And there's a referencing system which allows you to locate any particular chapter, verse, word, and even segment, so that you can find others which have the same one. There's a complex referencing system. Now, on top of that, each Arabic word is quite complex. So a typical word may have a root, such as this verb, and there's a conjunction at the start of it, and there's a subject and object pronoun after it. So you have to segment the words into individual parts. And there's quite a lot of detailed information about what the grammatical categories of each of the individual parts are. So this is, reading from right to left, a conjunction followed by a main verb, followed by a subject pronoun, followed by an object pronoun. And for use by Arabic grammarians, an awful lot of Arabic grammarians are in the Arab world and prefer to speak in Arabic, so there's also automatically generated an Arabic translation of the grammatical description. Now, that, somewhat more complicatedly, there is a parse structure, a tree or diagram for showing the grammatical structure of each sentence, based on the traditional Arabic grammar i'rab rather than modern linguistics. There's also a quite complex ontology, that is a set of all the entities or things. Every noun or pronoun refers to something, and this is linked to from the text, and you can find all the instances going back from the ontology. On top of this, quite complex framework for collaboration, a message board so that anybody finding anything wrong can point it out, and a large set of downloadable resources, including the software and the data. This is proven to be used by researchers and members of the public worldwide. A map showing you where most of the users are, mainly America and Britain, but around the whole world. And not just lay people trying to read the Quran, but many of the research uses. So as far as AI and computational linguistics, what's new? Well, it's the first tree bank, a set of parse trees of classical Arabic, and it's the only one that's actually freely available. And it's also a formalism for traditional Arabic grammar used in machine learning parsers. This is a novel part-of-speech tagging system, so each word has a quite detailed grammatical category, gleaned from the traditional Arabic grammar textbooks, but formalised in a computational sense. And Kaiser's also developed a parser which, taking examples of these trees, can use machine learning to work out the patterns for parsing and then apply the parser to new sentences, other sentences in the Quran and potentially other classical Arabic sentences. So how does he meet the criteria for Postgraduate Researcher of the Year, able to communicate research to a lay and non-specialist audience, impact on the rest of the world, and engagement to the public? Well, there is a feedback page on the website, including lots of feedback from members of the public, but also some academic researchers, non-specialists, such as Professor Michael Arthur, Vice Chancellor of Leeds University. And in terms of impact, well, obviously there's over 1 million users have in the past year alone, and obviously it's just starting, so there's going to be many more. And there's lots of really interesting users, like a chaplain in the correctional centre in the state of Missouri is an interesting example. Its scientific impact to the subject area is already published many papers, including a significant journal entry. There's quite a few citations, even though he's only halfway through his PhD, and lots of positive feedback from other researchers. And there's been newspaper articles, for example, in the Muslim Post, and of course the website itself has got lots of public users and feedback. That's definitely public engagement on a worldwide scale, I'd say. So, to conclude, well, this isn't a conclusion because he's only halfway through his PhD project, given it's a part-time PhD project. So I hope you're going to give him the award of Postgraduate Researcher of the Year. If not, you can always come back and try next year.